Hello everybody, this is Mrs. Snook with section 5.3, the slope-intercept form. Our objective is to write linear equations using slope-intercept form and then to graph linear equations that are already written in slope-intercept form. The first thing is some definitions. A linear equation is an equation that models a linear function. So it would look like a straight line. And then part of your linear equations is the y-intercept. So a y-intercept of a function is the y-coordinate where the graph crosses the y-axis. Oftentimes you'll see it written like this, 0 and then b, where b is that y-coordinate. Sometimes we'll just tell you b equals, and then we'll give you a number. And the big form for linear equations for today is the slope-intercept form. And that is y equals mx plus b, where m is the slope and b is the y-intercept. And so for any of these non-vertical lines, you can write the equation in slope-intercept form. If you're doing a vertical line, all bets are off. So part one is we're going to identify the slope and the y-intercept just from the equation. So keep in mind that y equals mx plus b. M is your slope, and b is the y-intercept. So with that in mind, you can literally look at these equations, and without doing any work at all, you can identify the slope and the y-intercept. So example 1, y equals 5x minus 2. My slope is the coefficient in front of x, so that's 5. And the y-intercept is the number that's hanging off the end there, negative 2. All right, let's do another one. Take a look at this equation, y equals negative 1/2 x plus 2/3. Slope is the coefficient in front of the x, so it can be negative and it can be a fraction. And the y-intercept is the number off the end there. That can also be a fraction. So here we have slope is negative 1/2 and the y-intercept is 2/3. All right, part two, we're going to go the other way now. I'm going to give you the slope and the y-intercept, and your mission is to write the equation in slope-intercept form. So example 3 says, what is an equation of the line with slope negative 4/5 and y-intercept 7? So slope, that's m, equals negative 4/5. And then the y-intercept, that's b, equals 7. Now all I have to do is take my slope-intercept form, which is y equals mx plus b, plug in the m for the m, so negative 4/5 x, and then plug in the b, plus 7. And that's your equation. Part 3. So we know that there's graphs associated with these equations, and we know they're straight lines. So you should be able to look at the graph of the line and write the equation. So let's take a look at example 4. There's two things that I need. I need to know the slope, and I need to know the y-intercept. So when I look at the graph, the way I'm going to get slope is by doing rise over run. I'm going to pick 2 points on the graph, pick points that are actually lined up to the grid lines. And so the 2 ones that I colored in there, those are the points I'm going to use. And to get from this first point, I go up 2, and then I go to the right 1. So my rise is 2, my run is 1, so my slope equals 2. Notice that this is uphill, so make sure your slope is positive because this graph goes uphill. The next thing I need is the y-intercept, and that's where the graph crosses the y-axis. And right there, that's where it's crossing. And so that is at -2. So then b equals -2. So my equation is just y equals 2x, so mx, 2x, plus b. B is a -2, so -2. My next example, notice that this line is going downhill, so make sure your slope is negative. Pick 2 points that line up on the grid. I'm going to start here. I have to go down 2, actually, yeah, down 2, and then I have to go to the right 2. So my slope, my rise is down 2, so that's a -2, and my run is to the right 2, that's a +2. So my slope is a -1. My y-intercept is right there, and that happens to be 2. So now my equation is y equals -x plus 2. You don't have to write the 1. That's assumed. So the negative is because it's -1, and I'm not writing the 1 in front. Downhill, negative slope. Yep, I have a negative there, so I know I'm good. All right, now what if I just give you 2 points? I don't give you a graph. I don't give you an equation. All I do is I give you 2 points that this line goes through. And I want you to write the equation in slope-intercept form. So I want something like this. You need to figure out m and b. M I can get easily enough. I just do y2 minus y1 over x2 minus x1. I'm just going to use our coordinates. So -8 minus 1, so there's my y's, over, and then I'm going to do 5 minus 2. So I get a -9 over 3. Don't leave this like this. Please reduce it. That goes to -3. So I've got m. I still need b. This is where I'm going to use the points. I'm going to pick one of those points. I can pick either one that I want, but 2, 1 is nice, simple little numbers, so I'll go for that first. And just to show you where we're at, we now have y equals -3x plus b, and I'm trying to figure out what that b is. So what I'm going to do is I'm going to plug in the x and the y from that point that I chose. So y is 1, x was 2. I don't know what b is, so I'm just going to leave that as a variable. And this is now a simple little equation that I can solve. Because what I have here is 1 equals -6 plus b. Just add 6 to both sides, you get b equals 7. So now I have m and b. I'm ready to write my equation. Y equals mx plus b. And I'm going to plug in what I have. So I put -3 in for m, and I put +7 in for b. And that one is done. Part 5. Now we're going to graph a linear equation. I'm going to make my axes. So this is the y-axis. Here's the x-axis. Looking at my equation, I know that my y-intercept is -1. So I'm going to put a point right there at -1. I also know my slope is 2. I'm going to use the slope to get another point. I need 2 points to graph a line. My slope is 2, so that means rise over run is 2 over 1. So from my first point, I'm going to go up 2, which brings me right here, so up 2. I'm then going to go over 1. And right here is my second point. So now all I got to do is sketch in my line. Now I like to have some extra points just to make my sketching easier. You do not have to do this, but I do prefer to put in an extra point or two. It just makes it easier for me to sketch correctly. So there's my graph. All right, the last thing we're going to do is we're going to model a function using a real-world situation. We have a plumber charging a $65 fee for a repair plus $35 per hour, and we're asked to write an equation to model the total cost y of a repair that takes x hours. So this is a word problem, so do your 3 reads. First read, you get the story, and the story is that a plumber is repairing probably a sink, maybe. And that plumber is charging a $65 fee, like just to go there, just to come to your house is $65. And then for every hour that they're there, they charge another $35 on top of that $65. So there's our story. The second read is for what's it asking you to do. And it's asking you to write an equation to model the total cost of the repair, which is y, and x hours. And then the third read you would do is for the information, and you would get a $65 fee and $35 per hour. Let's go ahead and jot this information down. So y represents total cost. X is going to represent time or hours. And I know that the plumber is going to charge a $65 fee just to come to your place. And then for every hour that they're there, they charge another $35. So that's where I'm getting my 65. That's the amount just to come. And then every hour they're there is 35. So I'm going to multiply 35 by x. Now this looks like a linear function. Let's put it in slope-intercept form. So that means I need to put the 35x in front. So y equals 35x plus 65. And there is your equation. That's it for today. Thank you for watching the video and have a great day.